What is CORS? So CORS stands for Cross-Origin Resource Sharing. CORS allows you to break the same origin policy of a browser. And the same origin policy of a browser I'm going to explain with a few slides. So let's imagine that you go to moo.com and you load the web page from moo.com. And within that web page came some HTML, some CSS, and some JavaScript. And when that JavaScript ran, that JavaScript then requested some data from foo.com. Perhaps foo.com has an API that it needed to request data from. So it sends a request to foo.com, and then foo.com does its processing and sends a response. But the same origin policy means that by default, any further requests that need to be made for additional resources, they must only come from or be sent to moo.com. So because the JavaScript requested some data from foo.com, when that data is returned, it's blocked by the browser. So the browser doesn't let that data propagate into the rest of your JavaScript code and your application itself. That is the same origin policy of browsers. And the reason it exists is because it's a security feature. Let's say you own foo.com, and for foo.com you created an API to support the running of your website. Somebody else at moo.com, some unscrupulous developer, decided, hey, I can't be bothered to create my own API, I'm going to use the one I found on foo.com instead. So what they do is they don't even contact you, they just secretly write some JavaScript code on their web page, and then when somebody visits moo.com, it gets the data from foo.com and shows that on the web page. So the same origin policy basically stops that from happening. It blocks that at the browser level, and it's a security feature. So that's what it does by default. It blocks by default. And CORS, Cross-Origin Resource Sharing, is a mechanism that lets you selectively unblock certain requests. For example, in this scenario, if foo.com and moo.com were owned by the same person, they might want to set up CORS so that their website from moo.com could request data from foo.com. And that's what CORS really is, and that's what it does. It's a way of opening up that rule so you can selectively start letting people get access to servers from different origins. So how does it actually work? Now in this scenario, let's imagine we're the browser and we've loaded up data from moo.com, and then we have a JavaScript piece of code which is requesting data from foo.com. Now again, by default that's blocked, but if we wanted to open up that access, there's two ways in which that happens. Two high-level ways in which that happens. Now the first one I'm going to show you is just with a normal basic GET request, because that's the simplest to understand, and the other requests are actually based upon the same logic as the GET request, but with a few more features. So that's why we're starting with just explaining the GET request first. So what happens? Some code in the browser issues a GET request to foo.com. Now the browser, in the headers to that request, in the headers to that HTTP request, will add the origin. So the origin is the domain whose website the browser is currently displaying. So currently we're displaying data from moo.com, so the origin, the browser, will set to moo.com. And then the servers at foo.com will do whatever they need to do, and then they will return a response. And for CORS to take effect, the response has to have the header access, control, allow, origin. And if the value to that header is moo.com, or I should say if the value to that header is the same as the value to the origin header that was sent in the request, i.e. the same domain, then the browser lets that response propagate through your application and basically passes it back to your JavaScript code and essentially lets your application run. Now, as well as just passing back the same domain as the origin, the server could also pass back in a star. And this means, hey, I'm foo.com, I don't really care who's using my API. everybody's allowed. So if it's star, again, the browser will go, okay, that's fine. I'm going to let that through. However, if foo.com returns a different domain, so perhaps google.com, but specifically something that doesn't match the origin that was sent in the request, then the browser blocks that response from propagating through the rest of your application. Your JavaScript code won't even see that response. So just to summarize, to enable cross-origin resource sharing, the browser will always send the origin to the server when sending a get request, and it expects the server to respond back with a header called access control allow origin, whose value is either the same as the origin domain that was sent in the request or star. Anything else, any other value, or if the access control allow origin header isn't present in the response, that will cause the browser to block that response from propagating through to the rest of your application. Now here's an important point, and this is something that I see candidates failing at quite regularly, and that is they kind of forget, or they perhaps don't realize, that it's the response that's blocked. It's not the request going out to foo.com that gets blocked, it's the response that gets blocked. And that's super important to know because it explains why we do it slightly differently for puts and posts and deletes. Now the thing to remember about gets is the contract or the promise with a get request is that it's not going to change anything on the server side. So if you issue a get request to foo.com, the promise, the contract is that foo.com is just going to return some data. It's not going to change anything in its database. It's not going to change some state. It's not going to destroy a resource. It's not going to create a resource. It's not going to change state. It's just going to return something. But if we were issuing something like a put or a post or a delete, let's give the example of a put. If I was issuing a put request that would get sent to foo.com, foo.com would perform whatever processing that needs to be done for that put request, issue the response, and if the response fails CORS, for whatever reason, the response gets blocked. But that doesn't matter. That doesn't help us because by that point that the response is blocked, foo.com has already made changes to its database because we issued a put. So if you think about it, for gets, this method of CORS works, but for puts, posts, and deletes, things that actually change data on the server side, because we're only blocking the response, it's not stopping those requests going out, which kind of defeats the purpose of blocking anything, I suppose. So how CORS gets around this is by sending something called a pre-flight request. So a pre-flight request is basically a HTTP request of type with the method options. So if we were issuing a put request, the first thing the browser would do is actually to send an options request to foo.com. It would still set the origin as moo.com, the same as if it was sending a get request, but it would additionally send another header called access control request method, with a value being the method that it eventually wants to send to the server. So in our example, we eventually want to send the put. And what this is doing is the browser is basically asking, foo.com, it's basically saying, hey, look, I want to send a put. This is the kind of data I'm going to send when I send you my put. Is this allowed? Is this okay? And so what foo.com then does is it does whatever processing it needs to do, and then it issues a response. And same as before, it would set the access control allow origin to moo.com or to star, but in addition, it also adds another header called the access control allow methods. And this can actually contain a comma separated list of methods. So it can contain put, comma, get, comma, head, or just one, but it must at the very least contain the same method that's been requested in the request. So if we requested in the request via the access control request method header that we want to issue a put, we then see that put is available in the access control allow methods header in the response, and at this point the browser continues. So if any of those was not correct, so if the response didn't contain the access control allow methods header, or didn't contain the right HTTP method that we're requesting, or didn't have the access control allow origin with the right value, at this point the browser would block that response and it wouldn't then issue the put. But if everything is okay at this point, if this pre-flight little test handshake request, if this request and response came back successfully, only then will the browser then issue the put. And from this point forward, it's very similar to the GET request that I showed you previously. So we would send the origin, and then the server would respond back with the access control allow origin again. And if that is either moo.com or star, then again it would propagate to the rest of our code. So that's the basics of CORS. That's how it works with GET requests, and it works slightly differently with puts, posts, and deletes in that it sends a pre-flight options request first, just to check, just to see if the put, post, or delete is allowed. Let's actually go through a couple of examples using a tool on the internet. Okay, so this site is called test-cors.org. It's one you can go visit as well, and you can try this out. And I recommend trying this out yourself as well. So this website acts as both the client and the server, and it lets you test out requests being sent. You can change the server settings as well, so you can see how different responses cause different effects in the browser. So you can see on the left-hand side is the client. So this is the client sending panel. And on the right-hand side is the server. There's two panels. You want to choose local. And right now I haven't enabled CORS. So let's just see what happens when we issue the GET request. I'm going to send a request right now. So you can see in the console we've got an error. It says XML HTTP request cannot load, and then the path to the URL which we were calling. Then it says no access control allow origin header is present on the requested resource origin, and then the domain of the page that we're visiting is therefore not allowed access. This is the standard CORS error. You'll see this a lot if you start dealing with CORS and dealing with API requests to different domains. Let's have a look at the network tab. Let's give ourselves some space. So you can see it did send a GET request, and actually the status was 200. So nothing went wrong on the server side. It returned a status of 200. It was blocked by the browser on the client side. Let's have a look at the headers. So let's have a look at the request headers to begin with. So you can see we're sending the origin header, but then when we look at the response headers, you can see it's not returning. There are no access control allow origin headers returned. And that's why the browser is blocking this. Now, if we go back to the web page here, if I now enable CORS, so this is now going to enable CORS on the server side. And now let's clear the cache, clear the network, and then let's run this again. You see there's no errors in the console, which is good. And when we look at the network tab, we can see, let's again look at the request. We've sent origin. And in the response headers, the server has responded with the access control allow origin, and the value, if you see here, is the same as the one sent in origin. So the browser allows this response to propagate through to the rest of your application. Okay, so that's GET. Let's take a look at our other example of PUT. Clear the console and the network tab. And now let's send the request. Okay, we've got an error. XML HTTP request cannot load, and the path to the URL we're trying to call. Method put is not allowed by access control allow methods in the pre-flight response. Let's have a look at the network tab. So what you can see is that we're actually sending one HTTP request here. The method is options. This is what I explained before. This is the pre-flight request. It did return, so the status is 200. Now let's look at what the headers were for this. So we go to the requests. You can see that the origin is sent, but in addition to the origin header, it also sends the access control request method header, telling the server that actually we really want to send a put. That's our goal. And then the server returns back with the access control allow origin header, which is good, we want that. But it's not returning back the access control allow methods header. And that's what's going on here. It's going, well, so the browser's saying, hey, look, I've sent the pre-flight request to the server. I told it I wanted to send a put later on. And the server responded, but it didn't tell me whether or not it will allow puts to be sent. So I'm just going to block this response. So how to make this server return that header, so we go back to the server side on the right, is we can just type in put here, and this is what will get sent back in that header that we want. So now I'm going to clear the console, clear the network, go back to the console, send request. Remember, we're sending a put. Everything looks good. There's no errors in the console. Let's look at the network tab. And the first thing you should see is that there are 2 requests sent. One is the options request, the pre-flight options request, which must have succeeded because then the browser went and sent the actual put request. So let's have a look at the options request again. So you can see we've got the access control request method here. So we're requesting to eventually send a put. And then we're also sending the origin. And then in the response, we've got the access control allow origin, which matches the origin which we sent in. But additionally, the server responded back. Remember, this is the server. It responded back with the access control allow methods of put. So it's saying, hey browser, it's cool, I allow puts. And the browser goes, oh, awesome. You allow puts? I'm going to send you a put. So then it sends the put. And you can see it's just like a normal GET request from this point forward. We send the origin, and then it sends the access control origin in the response. And if they match, everything's fine. And the response propagates to the rest of your code. So that's CORS at a high level. There's a couple of other features to it. I'm not going to go into it in any more depth, but I will leave you with some materials in the resources section so you can read through that link and find out further details about the CORS and cross-origin resource sharing. There are in fact entire books written on this subject, so it's pretty deep. But I think just knowing this is enough for an interview question. So the important takeaways for this is that to make CORS work, you need coordination from the server side. If you receive a CORS error on the client side and you have no control of the server, there's nothing you can do. Whoever's in control of that server needs to make sure they're sending the right headers in response to your requests. So to get around the same origin policy of a browser, we can use CORS. How it works is the server needs to respond back with the access control allow origin header, and the value to that must be equal to either star or the domain that was passed in the origin in the request. And additionally, for puts, posts, and deletes, the browser will send a pre-flight request via the options HTTP method, in which it will additionally pre-check with the server to see whether the method that you want to call is in fact allowed.